The energy systems of the future will be intelligent and integrated. A set of cross-vector renewable technologies will take part of the new energy network. My name is Laura Ramirez, and today I'll talk to you about the role of microgrids in such a cross-layer system. After this video, you will be able to give a definition for a microgrid and also for its control system. Additionally, you will have the knowledge to elaborate on the main characteristics of a microgrid and its role in the future energy system. Microgrids are small-scale networks that have the potential to facilitate the integration of distributed energy resources, electric vehicles, and controllable loads. The integration of these technologies is expected to positively affect efficiency, environmental impact, and economic performance. But what is a microgrid exactly? Microgrids are considered to be the building block of the smart grid. In technical terms, according to the IEEE standard for the specification of microgrid controllers, a microgrid is a group of interconnected loads and distributed energy resources with clearly defined electrical boundaries that acts as a single controllable entity with respect to the grid, and can connect and disconnect from the grid to enable it to operate in both grid-connected or islanded mode. Now that we know its definition, let's take a look at the definition of its control system. According to the same standard, a microgrid control system is a system that includes the control functions that define the microgrid. In other words, a system that can manage itself, operating autonomously, and connect to and disconnect from the main distribution grid for the exchange of power and the supply of auxiliary services. Additionally, it includes the functions of the microgrid energy management system. This can be carried out by the microgrid controller if implemented in the form of a centralized control. Now, I'll refer to four main characteristics that a microgrid should always feature. First, a microgrid is an integration platform for local generation, storage, and demand. All of them placed within a local distribution grid. Local generation is typically found at low voltage levels, and it is known as microgeneration due to its low scale. Second, a microgrid should be able to work in two operating modes, grid-connected mode and emergency mode, also known as islanded mode of operation. Third, a microgrid should enable an active operation of the distribution network. Management and coordination of this architecture makes the integration of microsources possible. Fourth, a microgrid can operate in low, medium, or large scale. A low-scale microgrid could typically be a house with PV panels, power converters, and loads, having control at the house level. A medium-scale microgrid could be a factory. A big-scale microgrid can be of the size of a university campus or even much larger. Microgrids have several advantages compared to existing passive distribution networks. They are more resilient to failures, disturbances, and faults because of the possibility of operating in islanded mode. This mode can be enabled through the implementation of suitable control and protection schemes. They can provide a higher efficiency, especially because of the power that is generated at the point of use. Finally, they allow the integration of higher levels of renewable sources because they are designed to be integration platforms. What is the role of microgrids then? As you could have probably inferred from the definition and the characteristics, the main role of microgrids is to serve as an integration platform for distributed energy resources. Microgrids have the potential to provide a higher flexibility thanks to the higher generation levels of storage, as well as the implementation of intelligent control mechanisms. Higher flexibility means that it is possible to integrate more renewable energy sources. Unlike traditional networks, microgrids can be created in a modular manner, and this way they are more independently maintained, controlled, and expanded. For example, electrical components could be easily replaced, upgraded, and aligned with current standards. In summary, in this video, we defined a microgrid and a microgrid control system. We covered the four main characteristics that must be present in every microgrid. Then we identified potential benefits that microgrids can provide to both the main grid and consumers. Among these benefits, we can find higher resiliency, flexibility, and modularity. Also, due to the higher participation of renewable energy sources, microgrids can be more environmentally friendly than passive distribution systems.